Here we go. And then we're going to go big screen. So in your notebook, you should have 3.4. We're going to talk about IPs and what this is all about. Again, what is the function of a router, Ched? What does the router do? What does a router do?
Provide a network.
Yeah, he gives you your Wi-Fi. He also assigns your IP address with the DHCP. We're going to talk a little bit more about this. Okay? His job is to manage the flow of the data. Okay? He also has a lookup table of all the IP address. We can also block MAC address. We have a MAC lookup table where any device comes on to the router, he logs the time that he was on the network, and we can monitor him, we can control the speed, we can change the security, lots of things. And so basically, one of the most important skills, okay, Wendy, can you just, I need a little bit of note, thank you, is you need to be, right now you can just listen, you need to be able to create a SSID. What is SSID? SSID is the network name, okay? So when you use your phone and you see all the Wi-Fi names, they're set up from the router, okay? And there's a little setting that you guys will be doing is you need to change the name of your SSID. You also need to be able to enable encryption. That's so that people can't steal your password to get onto the internet. There's WPA2, which is the older protocol encryption, and if you can, you want to use the most newest one. It's called WPA3. Okay? We need to be able to change the IP address of router. That is like the door that you can access. Normally, routers, the standard router IP address is 192.168.0.1. This is standard, but each router usually it sometimes has the standard IP address at the back, or you have to go onto the manufacturers. This is called TP-Link, and you put in the model name and you Google what is the standard IP address, and that is used when you plug in your computer. You can access that by going on to the web browser and you put this IP address in and it will access inside this. And then we can actually program him. Okay? Yeah. So you'd have to, basically you have to Google the router name and you find out the standard IP and password. Each router is different. All right, so I want you to make a list in your notebook. What does router do? There is many things that router does, okay? So let's just make a list. You need to know, I would say, at least 6 things that router does, okay? Are you ready, Wendy? Number 1, router, it receives packets. So I want you just to write down this. What I circle in green there, Ched. Routers receive packets. What does this mean? So when you send email, when you send any kind of data, it collects all the packets and then later it's going to distribute this to all the devices to the specific device that needs that data. Okay? So receives packets. For example, you can get email. You can have photo. What else can you receive? You can want video. Okay? You don't need to copy this all down. You just need to know the heading. You can receive packets and understand what that means. Number 2. What is the second thing that a router does there, Wendy?
Finding destination.
What does that mean?
Find the IP address of the device that want to send the data to.
Yes, exactly. Finding destinations, it's used to find the computer's or device IP address. Is who gets the data. And we need to know their IP address. So just write down, it's used to find the destination. That means, where is the data going? Where is the data going? What IP address? What is the third thing there, Uma? What does this mean?
It means once the decision's been identified, the root of the same happens.
That's right. After we know it's going to go to a specific device, 192.168.2.1, for example, after we know where he's going to do, he's actually going to send the data to that device, only to that device. Okay? We call that forwarding packets. Okay? You can actually change a forwarding ports on the router. Okay, Wendy, what is the fourth thing that it can do?
Assigning IP address.
Okay, what does that mean?
Just like give a new IP address that is unique.
That's right. Normally what happens is you have a device, you have a MAC address. But the MAC address is used to identify what, Wendy? We studied this. It's used to identify the type of computer. If it's an Apple computer, if it's a Windows computer, it's the hardware, right? But does the device automatically have an IP address there, Uma? Does your computer automatically have an IP address in the NIC card? He doesn't. He doesn't have it. Whose job is it to give you an IP address? Uma? The router. The router's job is to give you an IP address. So what happens is that your phone is going to talk to the router and say, hey, I want to join the internet. I want to join the network. And you'll say, hey, okay, if the router has enabled DHCP, this is a protocol. If this is checked on the router will say, okay, I'm going to assign you an IP DJ. Okay? And then it can be a random that is free. Okay? It has to be free. Can you have two IP addresses that are the same on the same network, Wendy?
No.
No, because then I don't know how to talk, and this will have a problem. Okay? And so he's going to look, okay, I know your IP address is 1.1, so I'm going to give you 2.2. And because this is called an open IP address. And then the next time you come, I can assign you a different one after a specific time. These IPs run at a time, and I have to give you a new one. Okay? So this is really important, is it assigns the IP DJ to the device. You don't need to write all this down, you just need to understand that it gives you this. So if I was writing my notes, I just say, it gives you. Okay, so we're going to continue on. You should know at least 6, because you may have an internet question that says, what does router do? And you have to list at least 6 or 5, depending on the question. You can say, it receives and sends packages. It finds destinations. It forwards packages. It assigns the IP DJ. What else does he do? Chet. Number 5, what does he do?
Maintaining a router table.
What does this mean? Routers have a router table. What does this mean?
A table about who connecting the router.
Yes, exactly. Inside the router, it has a table, a list of all the previous devices, and it keeps track. When we go into him, we're going to go into the router today. Okay? In the second period of today, we're going to go in and you can actually see all the devices that have previously connected to him. I can see, oh, Chet, he logged into the internet. Uma, she's logged in, and I can actually see your IP address. And that's why Mr. Song, if he says, oh, can you give me a MAC address, he can use it to find out what student is using the internet and can see the data. Okay? Your data on the internet, it all goes through router, all through this device. Okay? So, for example, it's going to have a table. The table's going to have a MAC address, and then I know the computer, and it's going to also have an IP address. Maybe it also has a name, okay? And then it has a table here, and it keeps track of the IPs, okay? You can just draw a little table. Okay, it has a lookup table. Wendy, number 6.
Efficient pathfinding.
What does that mean?
The router finds the path that the data go.
Yes. So on a router there is multiple paths that you can go. Maybe you have a switch or a hub, okay? And it's going to find out what is the best way to go to that device. Here's the router. And on the internet, basically on a LAN, this is not really important. Why? It's because there's only one way to go. Agree or disagree? In this classroom, the router, if I put a wire, there's only one way for the data to go through that wire. Okay? So I'm just going to put a little star here. Can everyone look on the board here? When is this path finding important is more for the routers on internet. Because you have industrial routers on the internet, and it has to choose which way to go. Okay? So in your home, it has to choose, or called packet switching. Packet, can you write this word down there, Jed? Packet switching. Does anyone know what packet switching is? Have you heard of packet switching, Uma? What is packet switching?
I do know what.
Packet switching is it cuts your data into pieces. Each packet is 512 bytes. Okay? And so when you send the thing, it sends it in different packets. And the router will choose what is the fastest way. And so the packets go every which way through the internet, and then later it reassembles the packets at the destination. Okay? And so they have these routers on the internet. It's called like a switching router, okay? And what it does is it determines what road has less internet traffic, and then your packets will go different ways, okay? So this efficient path finding is more applicable to routers that are in the internet, not at your home. Okay, because at your home, you basically just have one wire. So there's only one destination. So it doesn't really have to figure out where to go. That's just a little thing there. Okay, who are we on? Ched, address management. What is this? Address management. Can you see that, or do I need to?
Maintains a table of MAC hardware and IP network addressing to keep track of which device is connected, where ensure accurate delivery of data.
Correct. That is the same as this. I already drew up this where you have an IP table, lookup table. You also have MAC data. So we already did that check. Okay, it has MAC information there inside your router. No problem. So that's the same thing. Uma, what is public IP address?
where the router gives the entire network a single IP address.
That's correct. Public IP address is something different. I'm gonna draw a little picture to give you an idea what that means. Okay, let me just scroll over here. Because how does your PC go to the internet? What does it need to connect to?
Network.
Yeah, we need to connect to a router. Right? We connect to the router. What is the next thing in the line there, Uma? After router, do routers automatically connect to internet? They need to go to other hardware device. What is that device called?
Like an external network.
It changes the data into a wave. What is this device? It's a modem. Agree or disagree? Right? Well, it's funny because this router is going to assign this PC a local IP address. For example, 192.168.2.2. Okay? But you have this modem that is ISP, and your internet service provider, he has to give you another IP address. This is called public IP. Okay? So this guy, he's going to have we call this the gateway to the internet. And he's going to give you what is the IP's name? It's called a public. Public IP address is the IP address looking from the internet. Here's the internet. When I look at your computer, I have to go through your modem. And your modem is going to give you a public IP. And it's going to look different. Maybe it's 0.2.48.1. It looks a little different. And they're not the same, but they're the same as the IP address. And so you have two IP addresses that you need to write. Okay? You have a PC. The router gives you local IP address. 听得懂? Local IP address is within a LAN. Public IP address is what there, Wendy? It's within a...
Modem.
What is the opposite of a LAN?
WAN.
It's a WAN. Okay? Can you copy that? So you need to understand that each device can have more than one IP address. One is your local IP given to you by your router. Okay? The other one is called a public, and that's from your modem, the ISP, the internet service provider. He says you can have access to the internet, and they're going to give you a public. That means public means that people can see your IP on the internet. And so if you don't want someone to see your IP, what can you buy, Uma, that can hide your IP? You know how you can change your IP address to be in the UK, and you can go and watch YouTube? What can you buy? Yeah, you can buy a virtual private network. And what this does is it changes your public IP to pretend that you're in the UK or some other country, and then you can watch YouTube. Or you can, it's just like copying, okay? It's just like changing your public IP. But will a VPN change your local IP there, Uma? What does it change, your VPN? Your local IP or your public IP? What do you think? Yeah, it changes your public IP, because public IP anyone can see. I can see Wendy's on the internet from the internet, because that's the port that you're sending all the traffic through. It's through your modem. Okay? So the hacker, first he has to find your public IP. Then from your public IP, he finds your router's IP, and then he got you. Okay? That's why IP address, they change. They don't always remain the same. Because if they always remain the same, the hacker can easier find you.
And how does Mr. Newson, how does the hacker to get to know that?
So anytime you connect to the internet, your ISP will have a list. You know that table? They have access to the list, and they can, if they hack the internet service provider's router, if they get into the router, they can find all that data. I will show you. We're going to go into the router today, and then you can actually see what this is looking like. Okay? You'll see the thing. It also shows you the time when you went on to the router, all the information. Cool. So, last one. Wendy. What is the last thing router can do? Router is a big topic. It can do many things.
Gateway and firewall.
Okay, what does that mean?
Like act as a firewall something to protect the IP address on your device.
Yes. Do you know what a firewall is?
防火墙.
Firewall is, it looks at the data going into your router and sees, is this good data or bad data, right? So firewall is, you know how in China you can't go to YouTube. Why? Because they block it with a firewall. Okay? Firewall, it just says, if you try to send this data, I'm going to stop it. Okay? Firewall is to protect you from people trying to hack you. Okay? So, gateway, DGOT, what it means is when you're accessing the data, it's like a chang, it's like a wall. And this is in your router. What he's going to do is he's going to look at this. Is it okay? This is called a firewall. Firewall is we have certain data. You can actually look at the data. Does it look safe? If it's safe, then he's going to send. If not, we stop. That's what a job of a firewall is. It looks at the sender's IP and it looks at the packets and it says, is this okay to send on the thing? Does it have virus? Does it have malware? But not all data it can find. And that's why you should have some software on your computer to find the bad stuff. How to say virus in Chinese there, Wendy? How to say virus?
病毒.
病毒. You know, there's viruses, your router can help protect you, and there's also other software. Cool. Does everyone have 9 things? I think on the test, maybe they asked 5. At least 5. But you should have those lists, and you have access to that. Okay. Now, there are protocols. The biggest thing we need to talk about is IP protocol. What is the IPv4, IPv6? Your router also is in charge of protocol. What does protocol mean there, Wendy? You've been studying about protocol. What is protocol?
It's the communication between 2 or more devices.
Okay. Protocols are basically the rules.
The rules.
The rules of sending data. Okay? So in your notebook, you should know protocol is the rules for sending data. The very first, these are the most 2 common rules that you must know. What is TCP rule? Uma, what is TCP rule? And what does that rule do? What is his job? Yeah. Very good. Write in your note. TCP is the transmission control protocol. His job is to break your data into packets. 1, 2, 3. His job is to put the packets back together. Okay? His job is to find out errors in transmission. His job is to resend lost data. Okay? So you should know about three things. TCP is transmission. It's when the data is sending to the destination. How does that all work? What are the rules? That's the protocol called TCP. This is the same as the Ethernet protocol. Ethernet protocol falls under yesterday. You know how we make that wire? When we had that wire that go, it sends the data and then it has a wait function. That's like a transmission protocol. It's one of the more common ones. There's many, but you also know some higher level protocols like email. What is the email protocol there, Wendy?
The POP.
Yeah, there's like POP3. You don't need to know this, but in A level, they have different protocols like POP3. POP3 is for the email. What is the other protocol name?
SMTP.
SMTP. This is email server. And it saves the email, and then when you get it, it syncs the emails. Okay? So there's a whole bunch of these different acronyms or different rules, and the router will have it. But the most important one that you guys need to know is TCP and IP. Chad, what is IP protocol? What is its job?
Routes the individual packets between sender and receiver.
Yeah. The IP protocol is basically the address. Okay? It's the path. Well, not the path, yeah, it's like how to go there, right? The address path of who's going to get the data. So they usually say TCP/IP, okay? And the router's job is to deal with protocols and assigning the IP DJ. So let's talk about the IP DJ.
Sir, I need to copy that to.
Can you, you don't have your laptop?
No.
You only need to write this there, Ched. I will highlight what you need to copy. TCP, so copy this.
Yeah, I copy.
And then what it does,
Copy the pro.
I will write right here. The thing that it does is packets. Packets means that it breaks it up into pieces. Okay? And the next thing, it puts packets together. Okay? The third thing it does is detects errors. Just write error. And the fourth thing that he does is resend lost data. Resend lost message.
I lost the data.
Yeah. Okay? Just copy the green. You want to...
I need to write an IP protocol.
IP, you just write IP is the address. It's the address. Okay?
Okay.
Do not copy, I think I taught this to Wendy, is when we're looking at PowerPoint and stuff, don't copy the information, you want to simplify it, make it Gen. Because if we copy, then it's just, it's going to waste time.
Okay.
It's going to waste time. Okay, here is the important thing for today. We need to learn two things. We're going to talk about the IP address, okay? The main function of a router is to manage protocols. And the most important one is TCP/IP. And right now I'm going to focus on the Internet protocol. Are you ready? Internet protocol, I want you to write down, we have two types, IPv4 and IPv6. Write that down, Jay. IPv4 is old. IPv6 is new. You need to know that. Why do we have? Uma, do you know why we have a new protocol? What's the reason? Yes, because we are running out of IP addresses. Because if you have 1 billion people, and how many devices do you have that connect to the internet? I have a phone, I have a laptop, I have a TV, a smart TV, I have an iPad. So if you had 3 devices for 1 billion people, that's 3 billion devices. And IPv4 cannot do that. Does everyone in the world have access to internet? No, but as time goes on, more and more people use the internet. And so we have a problem. We're running out of addresses. Okay? And that's why your router will change IP addresses when you connect to the internet. Okay? Because sometimes we have to share old and new IP. So IP addresses can change. But what you need to know, 写 IPv4 is 32 bits. Write this down. IPv4 uses 32 bits. And what does it look like? IPv4 looks like this. 192.168.2.1. Each group, it has 1, 2, 3, 4. It has 4 groups of a range between 0 and 255 of denary number. Okay? If you add this up, each one of those is how many bits to get 255? Bag of bits? Each is 8 bits. You're going to get a total of 32 bits. If I want to find out all the different combinations, it's 2 to the power 32. This is the maximum number. This is the maximum number of devices. And it's a big number, but it's not enough for the world. And that's why the engineers of the internet said, hey, we need to make a new IP address. Okay? Because the old one, still the majority of people today use IPv4, but in your lifetime, we're going to have a big problem. We have to change to IPv6 because it's the okay? This is IPv4. Okay? Now, IPv6 is new. Write down this, IPv6. It uses 128 bits. 128 bits. And it uses hex and denary numbers together. This only uses denary numbers where each group can be a number between 0 and 255. Whereas, look at this. This is an example of IPv6. It uses 4 hex numbers separated by colons. This is how you can identify. You must be able to identify, hey, is this IPv4, IPv6? You need to know. You also need to know the key difference. 32 bits and 128 bits. Other key difference is they use colon. You need to copy this there, check. IPv6 uses 128, uses hex number here, and it's separated by colon. How many groups does it have there, Uma? How many groups here? This one has 4 groups. How many groups does IPv6 use? We have 1, 2, 3. Oh, this way. I think this is a double colons used for it. Let me see. 3. Is it 5, 6? 4, 5, 6? Is it just 6 groups? I don't think so. Let me think about this. Because I remember they use double colon to isolate something. Can you quickly Google there, Uma? How many groups are in IPv6? Is it just 6 groups? Because I know the double colon.
8, 16 bits equals before hexadecimal.
So it's 8, correct? So if you use double colon, this is like a hidden group. How many groups does it have? Okay, it uses 8 groups. Okay? This is a key thing that you can copy down. Where IPv4 uses 4 groups of 8-bit number. IPv6 uses 8 groups of basically 4 numbers. Okay? Using the hex and number there. So this is a key difference. You need to know the difference between them. Here's a little comparison. IPv4 uses 32-bit. It can serve 4.3 billion people. That's a lot of people. It still works kind of today, but we're running out of devices. IPv6 is using 128 bits. It's billions of addresses. The format, it uses 4 groups separated by the dot. IPv6, it's separated by colons. It has 1, 2, 3, 4, 5, 6, 7, 8. 8 groups. IPv4 is secure, but depends on application. IPv6 is more secure. Okay? So here's a question. Wendy, can you read the question and let's answer it together as a class.
The CCTV cameras are connected in a network and transfer the data
Wirelessly
wirelessly to the central computer. Each device on the network has an IP address. Complete the description of IP addresses.
Okay, an IPv4 address contains how many groups? Chad, how many groups are in IPv4?
2 groups.
If you have, let's write out an example. 192.1668.2.1. How many groups?
4.
Yes. The answer is 4. Each group is represented in how many bits?
32.
Uma. Is it 32? I don't think so. How many bits to get 255? 1, 2, 4, 8, 16, 32, 64, 128, 256. How many bits to represent? How many bits to represent the Denner number 255? It's 8. Each group has 8 bits. Okay? What is 8 times 4? Is that 32? Okay? So you have to think about each group. Okay, next part. An IPv6 address has how many groups there, Wendy?
It contains 6.
No.
8. 8.
8.
Yeah, if we scroll up, let's have a review. Let's have a look. It has 8 groups.
But why 8 groups?
Pardon me?
I mean, why 8 groups?
It's much longer. It's much longer. Okay? That's why. Each group is represented in how many bits? We have like 2A, 3F. And then it's separated by colon. How many bits for this? Each letter is how many bits? A is how many bits?
10.
F is what? It's 1, 1, 1, 1. Agree or disagree? So each one is 4, is that right? What do we get? 4 times 4 times 4 times 4. What is 4 times 4 times 4?
256.
Well, this way. I think it's going to be 30. It's, I'm pretty sure it's going to be 32 bits per group. Let's just have a look at the answer. Oh, it's 16. Sorry, I'm wrong. Each group is represented in 16 because it's not times, sorry, you add. It's 4 plus 4 plus 4. That's 8. So you just add it up. That's right. It's 16 bits. This is 16 bits representation. Multiple groups that contain zeros are replaced by what? If we go back up here, Uma. Yeah, you see we were missing some secret hidden groups because if it's represented by 0, they just put double colon. You see, colon represents 0, 0, 0, 0. Okay? 0, 0, 0, 0. So, what is that thing called? Colon. It's just a colon. Double colon, each group is separated by 1 colon, but a hidden group, okay, I guess we could say it's double colon because it's together. Yeah. Does it say double colon or just colon? Let's see. Let's check the answer. Oh, or they can have a double backslash. Double colon. Okay? Double colon. This will be part of your winter holiday homework. This is like the same question that kind of shows up. Okay? But it's important to understand IP address. Okay? We're going to skip this. This is for your winter holiday. You just answer that. Okay? We already studied this. What is, Uma, we talked about public. What is the difference between public IP and private IP or local IP?
Public only belongs to the router, and it's for everything.
Who gives you the public IP? Does the router give the public IP? Let's go back to the picture that we drew.
The IS.
Yeah.
ISP. ISP? Yeah,
Yes. From here, the local IP is given by your router. David, your modem has the public IP address. Okay? So it's a little bit different. One is from the access from the internet, and one is your local one. Okay? We already talked about that. Last thing, static IP and dynamic IP. Can you guys just write this down in your notebook? Static IP, you can, on your router, you have this protocol called DHCP, which stands for the Dynamic Host Control Protocol. If you enable this, your router will assign IP address. If this is not enabled, you're going to have a static IP address. That means that your IP address will not change. Okay? And sometimes you want that. Okay? Your router can have a static IP. But it's more better to have a dynamic IP because over some time it will change your IP. And so if a hacker tries to hack you, you have a different IP address. It's more safe. So what you have to remember, this one's a little bit more safe, but sometimes static means it does not change. And so if I have a device 192.168.2.1, it will always remain the same in my LAN. but then if I find your IP, I can actually find your data. Okay? I can hack you easier. And so when you set up your router today, make sure that you enable DHCP, because what he will do is he will change this and assign it, and there won't be a collision. Because if we have another device, it will ensure that we don't have the same device. If it's the same, the DHCP will say no. The answer, if you have static, you could have a conflict. Static IP can have some conflict, a collision. You could have two IPs that are the same. It is possible that this happens. But if two IPs are the same, you're going to have collisions. You're going to have errors in the transmission. And so sometimes you want to use static, but usually you want to have dynamic. Dynamic means, you need to know what this word means. It means it can change. Bien. Okay? Can you change the IP address, Chen?
No.
Can the IP teacher 可以变吗？
不可以。
可以变。
可以。
What cannot change?
Static IP.
对, static IP won't change. And the other thing that does not change is MAC. What is the MAC, Uma, what is the MAC address? What does he tell me? What information? And can he change? It can't change. What does the MAC address tell me? The media access control. What information does he contain? He contains the hardware. It tells me what type of computer yours is. Okay? Is it Apple? It has the manufacturer's ID. Okay? And this is embedded in the NIC card. It cannot change. Okay? And that's why if I know your MAC address, you can change your IP address, but you can't change the MAC address, and so you can always be found. You can always find a hacker. I can find your computer and then I find, oh, it's the MAC. It's like your thumbprint. It leaves your evidence. Okay, that's it. Our schoolwork. Here's our task. Is we want to set up a router. Okay? And this is a physical router. So our schoolwork. You need to open up your computers. Okay? Can you open up your computer? Do you have a computer, Ted? Your task is, I want you to click on this link. Okay? This link is a virtual router setup. Okay? So if you click on this link, let me get the clicker. Okay, you're gonna open up the OneNote. Okay, let me just move this away here. Move this away here. Okay. Are you guys able to, oh, there we go. I want you to click on this link. You see what this is? You guys are the hackers now. You need to do some research on how to set up. Right now, where am I, Wendy? Where does this link go to? Yes. What it is this is called a simulator. Right now, I'm inside a Cisco router. Okay? And in here, you can see we have Wi-Fi. I can click on the Wi-Fi and I can change. Look, we have DHCP. You can have subget mask and the IP address. Okay? And what I want you to do is you're going to research. This is your schoolwork task. is research how to set this up. Okay, I think I put it into here. Here's your tasks. Okay. You're gonna use that.
Where is the link? Can you see?
It's on the OneNote. This is your schoolwork. Research, I want you to change the name of the SSID to I Love CS. Okay? When you can do that, I'll check you off. Okay? You just click on the link, you find it. There's different tabs. There's like Wi-Fi, there's IP. Just you can change whatever. You can have some fun.
Where is it?
Don't worry. Try to find some encryption. You may have to Google. You want to make sure your Wi-Fi MIMA is safe. Oh, make sure you have to change to strong password. So make sure you use some dollar signs and some big and small letters. Make sure it's strong. You're going to show it to me. Verify it. You're going to tell me what your password is so that I can't hack your router. Okay, you need to everyone make your own password. Make sure you include the encryption. And I want you to change the local IP address of this to this IP here. Okay? I'll let you guys do that and enable the DHCP. Okay? So there's several checks for you to do. And so this is the schoolwork. Click on the link. It's up there. And then show me that you're done. Boom. And then you can work on your winter holiday homework. Okay? And then we'll do the real one and set this up after holiday to make a LAN party. We're gonna have a LAN party. Maybe we'll do Minecraft. Do you guys like Minecraft?
Why not?
We'll do some Minecraft stuff there, but you have to figure out how to set this up.
Is it just like we play Minecraft together?
Yes.
Big fun.
Yes, but we have to set him up. We have to set him up today. So this is your job. Okay, Chet, I'll be with you in a sec. I'm going to stop record. Let me just stop recording and then